Let's continue on the journey of normal linear equations. This time, we discuss angle bisectors. We have two intersecting lines, 40x plus 9y equals 30, and 5x plus 12y equals 14. These two lines form four angles. Our objective is to find the equations of their angle bisectors. Before we solve the problem, let's discuss an interesting way to create new lines based on existing lines using simple algebra. For example, adding up their equations. In the graph, we create a new line by summation. 45x plus 21y equals 44. The new line is not an angle bisector, but we can see these three lines passes the same point. We call they are concurrent. Why are these three lines concurrent? Assuming two existing lines intersect at x0, y0. Then x0, y0 satisfy the equations. You can find the values of x0 and y0 by solving a system of linear equations. But this is not necessary. We actually don't need to know their exact values. Sum up, we got 45 x0 plus 21 y0 equals 44. Therefore, x0, y0 is on the line 45x plus 21y equals 44. Therefore, all three lines pass x0, y0. If we multiply the second equation by 10, we got 50x plus 120y equals 140. The first equation is kept unchanged. The two lines are exactly the same as the previous ones. What would happen if we add them up? Sum up, we got 19x plus 129y equals 170. This is a different line. Let's compare. Before we multiply 10 on the second equation, the sum equation is closer to the first one. This is understandable. The first equation has relatively larger coefficients, and therefore it contributes more weight on the sum. After the multiplication by 10, the second equation has larger coefficients. Therefore, the sum line is closer to the second one. By adjusting the multipliers so that two equations have the same contribution to the sum equation, as a result, the new line is an angle bisector. Can we do that? And how? Yes. The answer is normalization of linear equations. For the first equation, 40x plus 9y equals 30, we calculate 40 squared plus 9 squared equals 41 squared. So the normal equation is the original one divided by 41. And for the second equation, the norm is 13. So divided by 13, we got the normal equation for the second one. If you don't know the definition and the calculation of a normal linear equation, please watch my previous videos for details. Sum up the normal equations and simplify it. We got 25x plus 21y equals a fraction. plug it in GeoGebra, and it is exactly the angle bisectors. It seems that we just unlock another property of a normal linear equation. But what are the theoretical basis of it? Both normal equations and angle bisectors are related to distances from points to lines. If M is an angle bisector of angle AOB, and the distances from M to OA and OB are MP and MQ respectively, then MP equals MQ. Let point P with coordinates capital X, capital Y be on an angle bisector of the two lines. Then its distances to the lines are equal. The distances can be calculated by plugging in capital X, capital Y into the equations and take absolute values. Again, please watch my previous videos for details. We have an equation with two absolute values identical. There's two cases. One, the two values are the same, or one equals the negative of the other. Simplify it, we got 21x minus 25y equals a fraction. This is actually the difference of the two equations, and the other one is the sum of the two equations. We already see 25x plus 21y equals another fraction. And these are the two lines. Thank you for watching my video. And the next time I will continue to discuss normal linear equations. I will discuss incenters and excenters of triangles.